Computer RAM, or random access memory, has undergone significant advancements since the early days of computing. The first type of computer RAM was core memory, which was used in the 1950s and the 1960s. It consisted of tiny magnetic cores which stored information by magnetizing the cores in different directions. Although it was very slow and expensive, it was a major breakthrough in technology for the time. In the 70s and 80s, dynamic RAM, or DRAM, was the standard form of computer memory. DRAM used a capacitor to store each bit of information, which made it faster and much more cheaper than core memory. However, it required constant power to maintain the stored data, which was a significant drawback from core memory. In the 90s, the development of synchronous DRAM, or SDRAM, improved computer memory speeds by synchronizing the memory controller with the clock speed of the CPU. This allowed for faster data transfer rates between the RAM and the CPU. SDRAM was followed by double data rate SDRAM, or DDR-SDRAM, which doubled the data transfer rate of SDRAM by using both the rising and falling edges of the clock signal. DDR-SRAM was succeeded by DDR2 in 2003, which increased the memory speed and reduced power consumption. DDR2 used a prefetch buffer, which allowed it to read the data in time and reduce the time required to access the data. DDR2 also used lower voltage compared to DDR-SRAM, which reduced power consumption. DDR3 was the next evolution of computer memory introduced in 2007, which further increased the data transfer rates and reduced power consumption compared to DDR2. DDR3 used a higher clock rate and improved prefetching techniques, which allowed for it to achieve higher data transfer rates compared to DDR2. Much of the same was true for DDR4 that was introduced in 2014, and is still used consistently nearly 10 years later in 2023. The most recent type of computer RAM is DDR5, which was released in 2020. DDR5 is the fastest and most power-efficient type of RAM yet, with data transfer rates up to 6.4 gigabits per pin and lower power consumption compared to previous DDR versions. DDR5 uses advanced error correction techniques to ensure data integrity, which is particularly important for high-performance computing applications like video games. In summary, computer RAM has come a long way since the days of core memory, and the development of faster and more efficient memory continues to be a key focus of computing hardware manufacturers. With each new generation of RAM, computer performance has improved, and it has become possible to perform more complex tasks and run more demanding applications. I think a good example of how far RAM has come is how the device that took astronauts to the moon in 1969 has 2 million times less RAM than a budget computer nowadays.